Welcome to Brain Vision.
Okay, so we have got the following molecule, which has the potential, we don't know for sure, but it potentially has three stereocenters. They're referred to as sites 1, 2, and 3. How might we determine if these are indeed stereocenters? Well, we can just look at these carbons and notice if they are in fact connected to 4 unique substituents. This first one somewhat obviously is. It's got a nitrogen, a hydrogen, a methyl, and then a CH2. Actually it's just a branched alkene. Walk down into it. So that certainly is. Second carbon is similarly attached to definitely 4 unique things. And finally, we have site 3. Once again, this definitively is a stereocenter given the 1, 2, 3, 4 rather unique things which it's attached. So we can simply begin by numbering these substituents by priority, this nitrogen being 1, this carbon which is attached to more than simply 3 hydrogens being 2, and this methyl group being 3. I will label the hydrogen as 4. It should be somewhat obvious that hydrogen is going to be the lowest priority substituent. And at this point we can go from 1 to 2 to 3 and determine whether that's clockwise or counterclockwise. In this instance, we find that it is a clockwise connection pattern. So clockwise, when you don't have the lowest priority substituent in the back, implies S configuration. So we have S here. As we move on to this second site, we can assign priority to the group that's attached to this carbon, which would be the carbon bearing the oxygen first, then the carbon bearing the nitrogen, followed by the methyl, and the hydrogen clearly being the lowest priority substituent. If we connect 1 to 2 to 3, we would have to do so in a counterclockwise fashion, and when we have the lowest priority substituent, corresponds as well as clockwise. In the other situation, it would correspond to S. So this is an S stereocenter as well. And finally, we have site 3, which oxygen is the highest priority substituent, followed by a carbon that is attached to 2 other carbons, and then a carbon which is attached to only 1 other carbon. Hydrogen, the lowest priority substituent, is in the back, so when we connect these 3 stereocenters, and we do so in a counterclockwise fashion, symbolized we have S stereo configuration. So in fact, 1 is S, 2 is S, and 3 is S.